All right, testing. So it seems like this will might not work because it is assuming addition and one subtraction. Hello. What's up, Malcolm VR? All right, how do we do this? With addition, say 7, right? It's 70111, right? Hmm. So 7 we can do with the same logic here. We see that 7 is actually 3 here, right? So what actually is 7? Seven is 2, not 3, right? Right, so we have off by 1 or whatever it is. Right, that is wrong, I think. Because assuming this one trying to go to so can we do? Can we minus? We either plus, right? 1 due to the water, and then we minus 2 to 3, right? Right? There's a combination of this plus or minus, right? So we can do minus 2 to the 2, right? That is 4. That give us 3. Or so that's 3 minus 1. No, minus 1, yeah. And then the 1, right? So you go to 8 because it look like you just plus 1 if you have a lot of these, eh? Like for example, binary of 12, right? So you just plus 1 here, 0, 1, 2, right? Binary 12 plus 0, 1, 2 plus 2 then. Oh, no. Plus, if you plus 2, you plus 1, or did you minus 2? Right, if you see, you want to zero out these, right? So you have 12. What is a good way to zero out 2, 11? There. 0, 1, 2. Right? What was that? 4? Right? So 0, 1, 2, 3. So if you plus 4, then you minus 0, 1 to minus 16, right? That'd be 0, right? Yeah. Sorry. Because 0, 1, 2, right? 2 to 2, sorry. Right, so what if you if it's the power of 2, right? So binary of 8, right? So you can just minus the power of 2, right? So what we see is if there is only one then subtract. If there is only one surrounded by 0, then subtract 2 to the I, right? If there is multiple one, then we plus add to the, what is it, minimum I, right? This will zero out all the 1 in front of it until the 0 because of carry, right? Carry you want like adding, right? So what else? Right? Is that all the case? So we will scan from the right to left and count the number of consecutive one, right? If the number of consecutive one is 1, then we just add 1, right? Which is minus, right? Is there any number with that binary of 39 here? So we have this many, right? So we would add 1 so that we get to 40. So the 1 gonna become here, right here at the 0, 1, 2, 3, right? 0, 1, 2, 3, right? So then we would minus 8, right? Right? And then because 0, 1, 2, 3, 4, 5, right? Then we minus 32, right? Yeah. That's the thing, right? Okay, so let's try that. Is the number fitting in 32-bit? I think so. 10 to the 5, right? Is less than 2 to the 32 minus 1, right? Yeah. So let's try that. We probably could try the dynamic programming later. So let's see if we can solve this with this line of thinking. We get some water. Okay. Okay. So video here is 1 equals 0. So we need to count the number of 1, right? So got a 1 and shift. We end and then shift left, right? Oh, we started up bit mass BM go 1 Y position gonna be 32, right? Y aisle is this Y I equal greater than 0, right? so we need to count the number of ones, right? So this is this one, is this one, is this one, yes. This is 0. Then, right, so how do we do that? So we would do if bm and bit mass and with the n shipped by probably 32, right? So shipped by 32 minus 1, right? 32 minus I, right? Equal right, so first 32 minus 32 is 0, then I minus 1, right? Equal to 1, right? So then we do count them up, right? So if it's not equal to 1, I mean this is has to reset, right? Right, so if we see 0, okay, that is 0, then basically here we would continue, right? Then we back to count 1 again, right? Right? So now we have to, if number of 1 is greater than 1, right? Then we actually do is we actually have n plus equal to, what is it, the minimum here, right? Which is, so what if there's something this will be plus 2 to the minimum I, right? J, let's just call it J for easier, right? So let's just do J equal to 0, right? So basically this is J here, right? So now and then J plus equal to 1, right? To go to the next one, right? So n plus 2 to the j, right? Okay, so now we can see here that is 2 to 0. We got this 0, 1, 2. So 1 here is 3, right? So 0 plus 3, 0, 1, 2, 3, right? We count it again. So bit mass. Bit mass at shift 1 and then shift left, shift right. Right? it is equal to, if the number of 1 is equal to 1, then we just minus 2 to the j, right? Okay, so basically, and yeah, something like that, right? So let's see, j here, oh, the bit mass should be the same out here, right? So we take every bit, we end them, and then we ship right to j1. Wait, no, this should be 32 minus I, right? That's 0, 32 minus 32, 32 minus 1, 32 minus 31, right, is 1. This is increasing. Okay, so my pen, so you start at 0, 1, 2, 32, and whatever your position is, you have to ship by 32 minus I, right? So that will be 32 times 32 is 0, 32 minus 31 is 1, 2 minus 32, and so on, right? Right? I think so. And you count the number of 1. The moment that you found that it is not, it is not 1, right? And you check the number of 1, and yeah. So what if you only found like 0, 0, 1, 2, right? Okay, so one position here, that means 32 minus 1 is, no, 32 minus 31, so you end and then you ship 1, okay, it is go 1, okay, count the 1, next time 0. Okay, so j is actually, okay, j should be the minimum 1 that we found, right? So that is 0. Okay. Okay, so how do we know? Yeah, j gonna plus the number 1, right? In case of only 1 here, right? Then 0, 1, 2, 3. Yeah, it would go to the next one, right? But the question is, j here is the position, right? So we have to do is start them off with -1, j equal -1, j equal to what position it is, I, right? No, no. How do we figure out the the j here, right? So the moment we need to have -32 minus, oh, that is actually 32 minus I, right? Is it? Right? So the moment we found this is the moment we count the operation. Okay. Right. And for float, what float? Unsupported why is it float? In so BM for B float. Why is it float here? Bit mass is 1, right? Check the message people sent me. So which one is float here? Can we print type BM type BM BM and type and I don't even know what is it. So n become float. That means this is the problem, right? So how about one shift j, no? Right? Right? This should make it not float. Negative shift count. What? So that fix that. Can we do end here? negative ship count. Okay, so if the number of 1 is greater than what is J here though? J, right? So probably because you have to start at 0, right? Right. Let's see. Negative 1 here. So J gonna be 0. Right, so the integer gonna be 54. So we found 0. Good. Then if the number of 1 is 1, right? Then we ship by that many. Right? Okay. So we also should put this. So this is too much printing. Print n. Just do that. And print the operation. Plus J, right? So print J minus, right? One found. Right, so 54. So 1 and 54, 0, right? So 1 and 54, right? 0. This is shift 32 minus 32. That's 0. Why does it say 1 found? What's going on here? One found. At what position? What is one found here? 39 and then 1. Let's just write down. PM nine. Two minus I. And bed up. Okay. Wait. Oh, this is the first one. The binary of 39. So 0, 1, 2. So J equals 0, B plus 1. So N become 8, good. And 0, 1, 2. And become, okay. Plus 1. So we plus 1. 0, 1, 2, 3, right? So after this, J gonna become J before J after. Zero, 1, 2, 3, right? Yes. And 0, 1, 2. And oh, the bit mask also had to shift. Right, so right now 0, 1, 2. What is the I here? Right? So the I is at 0, 1, 2, 3. The I is at 3. Right? So, but the bit mass right now is 8. The bit mass also have to shift. Right? Oh. What? It print too much? Wait, so you have 0, 1, you have 1, 0, 0, 1, 1, 1, 0, 1, 2, 3, 4, 5. Right, so your eye starting here, here, here. The moment you see 0, right, this one, so the bit mask already had that. Okay, so this is probably because so why can we not start at 0? Right? And we shift by eye, right? This will be yeah. 0, 1, 2, yeah. So the problem is the moment we see 0, right? The moment we see 0, what happened? So we have 1 here, okay? Now it becomes 0. Everything gonna be 0 out. This become 0, 0, no. 1, 0, 1, 0, 0, 0. We are here, right? Somehow we enter the loop. All the speakers so if the number of 1 L left, right? Okay, yeah, equal exactly 1, and the number of 1 is 0, then we do nothing. And so only when we're in this situation we would press the ops, right? And we keep going, so like this. Zero. What? Oh. So this is I plus 1, sorry. Zero, 1, 2, 3, right? Yeah. Two. What did we miss? So we plus 1 and we minus 8. right? Okay, so actually we can just do this, right? Negative shift count. What? What is going on? What does it give? Okay, got +1. We got -8, right? So the result gonna become right. Somehow infinite loop. Right, we got +1 -8. Then we're gonna become 32. Oh, the J after. So 0. We got 32 here. Right. Right, so now we gotta do number 32, right? Right, so this is 0, 1, 0, 1, 2, 3. So 0, 1, 2, 3, 4. Okay, so there's something wrong with the 4 here. Right? Let me go restroom real quick. Okay, we have 32. Then the first with plus 1, 0, 1, 2, 0, 1, 2, right? The number number is 3, so 0 becomes this one, right? Then the bit mask gonna find again. We wanna do number 1 we found is ah. So 3 good, and we plus 1, we got to, wait a minute, why does it become, oh, anyway, assuming this is correct, then after that J becomes 0, 1, 2, right? But the I is already at that position, right? So the moment we see 0, right? This is the moment see a 0, right? So basically here we gotta say oh, yes, continuous correct, but no. So let's put a count here. And count basically greater than 3. 1, 2, 4, right? Less than 4. And we print this. Right. Okay, so we got 40. Okay, hold on. 0, 1, 2, 3, 4, 5. Less than 6. How about that? Okay. We found. Okay, become 40. After is 3 good. 0, 1, 2, 3, right? 1 is 0. Oh, we stuck in infinite loop. Yeah. Right? Oh, okay. So J gonna go. Tie the music a little bit. So J. Become 3, okay? So the J is starting here. It's only gonna move by the number of 1. Okay, so we do, and this minus 1, good, we count, okay. But this, at the position 3 here, we found that it is 0. Okay, if it's 0, what is my base mass? Right, let's just print out PM. Okay, bit mass is 8, mean 0, 1, 2. Okay, bit mass is already at the position, right? The bit mass is 16. Okay, so we don't have to do that. We can just continue, right? Right, but we need to keep something, right? So what we do is 0, 1, 2, 3. So the bit mass already here, right? So we shift back 1 and vi minus 1, right? To go back, so that it's shift left again, like that. So the bit mass is 32. Okay, becomes this 0, 1, 2, 3, right? This is, okay, we plus 1, 0, 1, 2, 3, right? So the next time we see the bit mass again is 16. That is 4, right? So we found 1. We minus 8. Okay, so let's have it go to 7, 10, right? See if it passed. The infinite loop now. So bit mass is 16. Okay, 16, 0, 1, 2, 3. Right? Oh my god. Too many bishop. I'll have to come back to this later maybe. Ugh, oh my god. What this? I'll come back later. Seems like there's something wrong with the pattern here.